All right, let's check out number 4 through 6. In question number 4, the first thing that we're going to do is we are going to try to find the equation of the line tangent to the curve at a point. Well, you got to remember that in order to find the equation of a curve, all we need is a point and the slope. And we've already got a point, so the only real work that we have to do is find the slope and then plug in x equals 2 so we can find the very specific slope at that point. So here we go. We're going to start off right here, and I did a little low d high minus high d low, and I squared the bottom. Of course, I did a little bit of cleanup right here. And so I got a pretty nice little derivative right here, 2 over x plus 1. But of course, I'm not just interested in it everywhere. I'm interested specifically at the coordinate 2 comma 1/3. So if I plugged in 2 for x, I actually got the coordinate, I got the slope of 2/9. So now you'll notice that I have a point. I also have a slope, which means that I have a y minus 1/3. I've got a 2/9 of x minus 2, and I've got my nice little point slope form of a line. Pretty nice little problem. Question 5 changes it up a little bit. We now have one of those box problems where we want to find h prime of 3, and that is squarely going to be a little chain rule question. So the derivative of f of g of x would be the derivative of the outside function times the inside function. So f prime of g times g prime. Now what I'm going to have to do is plug in 3. So the first thing I need to do is refer to my chart here and find g of 3, which was 2. And also I want to find g prime of 3, which was right here, -3. So notice I did f prime of 2 and -3. But then my chart says f prime of 2 was -2. So I found that h prime of 3 is in fact 6. Now in a similar way, for part B, a quick chain rule is going to be the derivative of the outside, leaving the inside alone, times the derivative of the inside, which is g prime of it, but then I still have to take the derivative of this inside piece, which is 2. Now, of course, if I plug in 2, which is what it asks me to do, if I plug in 2, 2 times 2 is 4 minus 1 is 3. So I'm really doing g of 3, g prime of 3, and then I'm going to multiply by 2 from that chain rule over here. And we just kind of happen to notice that all of this information was exactly the same as we had right here. So since all of this information was 6, multiply that by 2, and we've got 12. Now question 6 is kind of an interesting one because it feels like a little bit of a blast from the past. We've got a ball that was thrown vertically with a velocity of 180 from a height of 200, I guess it actually doesn't say a height of 200 feet off the ground, but I can tell you that's what it is because that's my constant term and that comes from gravity. What is the maximum height reached by the ball? Well, obviously that's going to happen when the velocity stops because it quits moving up. So if we start with our general position function and we take its derivative, that's going to be v or s prime. A quick derivative, we're going to set that equal to 0 because at the moment that it comes back down, it's going to stop going up. And it comes out to 45/8. I did a little bit of simplification on my calculator, reducing those fractions. I guess I could have done it by hand. But then it actually doesn't ask us to stop there. It says, what is that height? This says when that height happened, but not what that height would be. So I need to take that 45/8 and I need to plug it back into the original function. And if I go through the process, and keep in mind, I just did y1 of 45/8. And I've got all of this, but then keep in mind, I made a simple statement here saying that that was the maximum height that occurred, and it was at 45/8 of a second. And that should finish up our first 6 questions. That's numbers 4 through 6. Hopefully that's helpful. Hopefully I'll see you guys soon. And we'll jump up on numbers 7 through 9 here in a moment.